answer. In that case, hydrogen bonding is not that much facilitated because of that bulkiness. Next one, the metal that cannot be obtained by electrolysis of an aqueous solution of its salt is, and here the if you look at the electrochemical series, in most of the electrochemical series you cannot see calcium. I don't know, maybe that is the reason they have included this question. In case of chromium and copper and Ag, if you are electrolyzing the aqueous solution, all of them, these three will get deposited at the cathode, understanding? This one and this one will get deposited at the cathode. Whereas if you take calcium solution, what will happen is at cathode the reaction will be this H2O plus electron, which is the electrode where the reduction happens? Cathode is the place where reduction happens. So at cathode what will happen is hydrogen will be liberated, half H2 plus OH minus. Understanding? So what is the answer? In all other cases, if you take copper Cu2 plus 2 electron gives Cu, Ag plus 2 electron gives Ag, Cr3 plus 3 electron gives Cr. But in case of calcium, it is not calcium, there will be a competitor, and that H2O, the H2 will be winning that competition. It's according to electrochemical series. On heating an aliphatic primary amine with chloroform and ethanolic potassium hydroxide, the organic compound formed is, what is this reaction called? Carbylamine reaction. And what will be the major product? RNH2 plus CHCl3 plus KOH. Remember, this is alcoholic potash, and what will be the product? RNC plus 3KCl plus 3H2O. And this will give a very foul smell, a bad smell. That is because of the presence of carbylamine or isocyanate or isonitrile. So this reaction is called as carbylamine reaction. They have asked a question directly on a name reaction. For the equation, SO2 plus half O2 gives SO3. If Kp is equal to Kc into RT raised to X, where the symbols have usual meaning, means Kp means equilibrium constant in terms of partial pressure, Kc means equilibrium constant in terms of molar concentration, R is the universal gaseous constant, T is the absolute temperature, usual meaning, then the value of X is, assuming ideality. So the X according to the equation is, so Kp is equal to Kc into RT raised to delta N. Delta N is the number of moles of gaseous product minus number of moles of gaseous reactants. So if you look at that equation, you can see how many moles of product? 1 mole of gaseous product, and how many moles of reactant? 3 by 2. So minus half, minus 1 by 2. Given below are the half cell reactions. Mn2 plus 2 electron gives Mn, and its electrode potential is given minus 1.18 volt, and the next the data what they have given is Mn3 plus electron gives Mn2 plus, and the electrode potential is 1.51 volt. What is the E0 for Mn2 plus gives Mn plus 2 Mn3? That's what you have to find out. And here you might have done many these type of problems according to Hess's law. And remember, this electrode potential is an intensive property. See here, if you take the sum of minus 1.18, and see, if you rearrange this equation, and if you do the same for electrode potential, you will not get the answer. For that, what you need to do is you need to convert this into free energy. There are two driving forces. What makes the reaction to happen? One is free energy, another one is cell potential. Actually, we measure the cell potential and find out the free energy value. So here, how we are going to work out this problem is, so you have to collect the data. First one is Mn2 plus 2 electron gives Mn, and it E0 is minus 1.18 volt. Immediately we will convert it into delta G. What is delta G? Delta G is equal to minus NFE, and what is the number of electron transferred? 2. So minus 2 into what is the electrode potential? Minus 1.18. We will keep F as it is for the simplicity. So what is the value? What is the value? Delta G is equal to 2.36 Faraday. Then next equation is Mn3 plus electron gives Mn2 plus. What is the E0 value? E0 is equal to plus 1.51 volt. So there itself we will convert it into delta G. So delta G is equal to how many electrons? Only one electron. What is the electrode potential? 1.5, right? We will keep Faraday as it is. So what is the value? Because minus NFE, right? So minus 1.5 Faraday. Is it right? Minus NFE minus 1.5 Faraday. We will keep that value over here. Delta G is equal to minus 1.5 Faraday. Is it right? Then you have to get an equation which is Mn2 plus gives Mn plus 2 Mn3 plus. So how do you extract this equation from this? So first one minus 2 into let us take it as first one, and this is second one. So first one 2 into second one. You try. So Mn2 plus 2 electron gives Mn, and delta G is equal to 2.36 Faraday. And second equation, if you take 2 Mn2 plus gives 2 Mn3 plus 2 electron, right? Then what is delta G? Here minus will become positive and you have to multiply with 2. So 3.3 Faraday, right? Then what is the sum? So you will get this equation, right? Are you getting this equation? This 2 electron and 2 electron will get cancelled, you will get this equation. And what is the delta G value? This is an important question. So what is the delta G value? 5.36 Faraday, right? Now this 5.36 Faraday you have to convert into electrode potential. Then delta G is equal to minus NFE naught. So E naught is equal to delta G divided by NF minus sign. So what will be the value you are going to get? What will be the value? Minus 2.69 volt. The spontaneity could be explained in terms of free energy as well as cell potential. If it is free energy, the spontaneous reaction will happen when it is negative. If it is cell potential, the reaction will be spontaneous only when the cell potential is positive. So will it be spontaneous? No, this reaction cannot be spontaneous. So the answer is minus 2.69 volt, the reaction will occur. Is it so? No. Then minus 2.69 volt, the reaction will not occur. The last one is the correct answer. Compressibility factor. It is another parameter by which we check whether the reaction, whether the gas is ideal or not. Okay. So another parameter which we use, the ideal condition of a gas is compressibility factor. It is generated like this. We know that PV is equal to RT. Right? This is what we call ideal gas equation. So if any gas is following this equation, we call it as ideal gas. So if you take PV by RT, it is supposed to be 1, provided it is ideal gas. We know that none of the gas is ideal. So the value will be other than 1. It could be greater than 1 or it could be less than 1. So whatever, we will not write 1, we will write Z. Z is what we call compressibility factor. By looking at the value of Z, you can say whether the gas is ideal or not. And they are asking, which is the van der Waals equation if the pressure is very low? So first we have to write the van der Waals equation. What is that? A by V square, V minus B is equal to RT. Right? If the pressure is very low, what about the volume? What about the volume? It's very high. Volume is very high. When volume is very high, we will neglect what? This B. Then the equation will be P plus A by V square into V is equal to RT. So that you can write PV is equal to A by V is equal to RT. The whole, in order to get the Z, what you have to do? The whole equation you have to divide by RT. So PV by RT is equal to A by RTV, PV by RT plus A by RTV is equal to RT by RT. And this RT by RT could be written as 1. Then what is, so we will take A by RTV this side, A by RTV. Then this, what is this PV by RT? PV by RT is equal to Z. So Z is equal to 1 by A by RTV. So which option is correct? A option is correct. The next one. This is from organic chemistry. In the reaction CH3COOH, it is reduced by using lithium aluminum hydrate, and you got a product that is treated with PCl5. You got a product that is B, and it is treated with alcoholic KOH. What is the final product? That's what the question. If you are treating CH3CO2H with lithium aluminum hydrate, as its name mentions, it is a very good reducing agent, and it could be used for transferring the CO group of acid to CH2. What will happen? This oxygen will get hydrated and it will give H2O, and this carbon will get hydrogenated, not hydrated, I am sorry, hydrogenated, so that CH3 CH2OH will be the product. CH3 CH2OH. And the next reaction utilize the special relation between phosphorus and oxygen, where when this ethyl alcohol is treated with PCl5, this oxygen will be absorbed by phosphorus and there will be the formation of POCl3, and this hydrogen and the CH2 group both will be facilitated with chlorine, so that you will get CH3 CH2Cl, and we got an alkyl halide. So next the Drungen potash will be coming. So what is the duty of Drungen potash? Elimination reaction. So after elimination, what will be the product? CH2 CH2.